with this 3x3 system, so we've got three variables, x, y, and z, and three equations, thus it's sometimes called a 3x3 system. What we can do is use two of the equations to begin with, eliminate one of the variables, and then we would have a system that has only two equations and two variables. And then we can solve that by substitution or elimination method. So the first thing to do is decide, well, which of the variables do I want to eliminate? I need to eliminate one of them. And I think that I'm going to use the x's, because if I use the last equation and the first equation and I subtract them, the two x's will cancel. I could also use this equation and just multiply by a -2, and then it would cancel that x as well. So start by eliminating the x's. So if I use the top and the bottom equation, I sometimes even like to label them as the top equation, the middle equation, and the bottom equation. So if I use equation A and C, it's going to be a 2x minus 3y plus z equals -1, and a 2x minus y minus z is equal to -3. And if I want these two x's to cancel, then what I need to do is subtract the two equations. So in here there's going to be a 2x minus 2x, those are gone. Keep in mind this negative needs to be distributed, so this negative multiplied over here is going to be a positive y. That positive y combined with -3y is -2y. And with the z's, the negative and negative will make a positive z, with another one makes two positive z's. And for the constant, this also has to be multiplied with the -1. So we've got a +3 subtract 1 is 2. Okay, now we've got one equation that has y and z in it. We need to repeat that. Go back to the a, b, and c, and I chose to use a and c, and I got an equation that has just y and z in it. Well, I'll do that again with either a and b or b and c, just don't use a and c again. I think that I'll use a and b. So if I use a and b, well, in order to get the x's to cancel, I'm going to need to multiply this one by a -2. So I can indicate that here, that I'm going to be multiplying the second equation by -2. So the first equation is 2x minus 3y plus c equals -1. And the second equation, multiply by a -2. And you can either do it as I did here, just put the number in front and then distribute it later, or you can go ahead and do it as you're transferring this down. So multiply this by a -2 is -2x, multiply this by a -2 is -2y, multiply this by -2 is +8z, and multiply this by a -2 is a +18. And then combine like terms. So these are going to cancel. These will make -5y. In here it's going to be a +9z, and then equals a 17. So now we've got two equations that have just two variables, y and z. So now we can put those together and solve for y and z. Well, I noticed that with this equation, it's got a 2, a 2, and a 2, so I could simplify that one, divide everything by a 2, and we've got negative y plus z equals a 1. And then take this equation over there, negative 5y plus 9z equals a 17. And I think that I'll continue using the elimination method. I'll get these z's to eliminate. So multiply this equation by a negative 9, and that will get the z's to be eliminated. Combine like terms. So in here, a negative times a negative is going to be positive 9y, and a positive 9y subtract 5 will be 4y. And this will be negative 9z, which will cancel that. And then there is a negative 9 times 1. So negative 9 and positive 17 is 8. And there we have it. Y seems to be equal to 2. Now, take that information and substitute it into one of these two equations that have y and z, and we'll be able to find z. And so we have, I'm going to use this equation that looks to be the simplest, negative what y is equal to plus z is equal to 1. So just add 2 to both sides, and we've got that z is equal to 3. So we have the y is equal to 2 and the z is equal to 3. And we're almost finished. Now I need to find x. Well, it was back here that we had equations with x. So go back to one of these, whichever looks easiest. I think that one, the middle one. And then find x. So finally, use equation B to solve for x. So it's going to be x plus whatever y is equal to, a 2, and then minus 4 times z, which is a 3, equals a negative 9. So this is going to be a negative 12, with a positive 2 is a negative 10, equals negative 9. And so add 10 to both sides, and it's going to be 10 minus 9x is equal to a 1. And then finally, because this is a point in space where these three planes are intersecting, write it as a point x, comma y, comma z. So it's 1, 2, 3. Now to check, what I should do real quick is check. I know that it works for B because that's what I use down here. I should also check that it works for equation A. So use a 1, a 2, and a 3. So 2 times 1 minus 3 times 2 plus the z value of 3. Does that equal a negative 1? So this is going to be 2 minus 6 plus 3. Does that equal negative 1? Well, that's going to be a positive 5 and a negative 6, and so the answer is yes, it works. A negative 6 and a positive 5 does equal negative 1. And then also check on equation C that it works for this. So 2 times the x value minus the y value minus the z value Does it equal -3? Well, this is going to be 2 minus 2, so that's 0. So it just leaves the -3 equal to the -3. Yes, it works. And so we have the solution 1, 2, 3.